vectors. So if you have to multiply a vector with a scalar, scalar means just a number, something like that. So if it's just a number without any direction or anything, so something like if you have a is equals to 5i plus 4j plus 2k. So if you have a vector like that, and if you want to multiply by 2a, so that means this 2 is a scalar. If you want to do like that, then what you have to do is you have to multiply this 2 to this whole thing right here, 5i 4j plus 2k right here. So when I do this, I multiply this 2 with this, 2 with this, 2 with this, just like any algebraic expression we have. If you have to multiply by 2, however you do it, that's how exactly we do it, okay? And that is going to be 10i 8j 4k would be our answer. So that's exactly what given right here, which is multiplying a vector with the scalar changes the magnitude but not the direction. Of course, like, did I change anything, I, j, k or anything? We just kept the same thing. Only thing is we just changed the magnitude of it. So that's what is the multiplication by vector. Oops, not that, this one right here. Okay, now if you have to do the scalar product of two vectors, so if you want to multiply two vectors, then that is called a dot b. So if you want to find out just the magnitude of those vectors, so then you do this way, a dot b. Okay, just the magnitude. If you want to get the scalar number as an answer, not a direction of it, then you do multiplication like this, and then we always make sure that you see a dot. There is a difference if you put a dot or like a multiplication mark, so make sure that you put a dot right here, and this dot means it's a scalar multiplication or scalar product. It means it's just going to give you how much would be the magnitude of it. It's not going to tell me in this direction or that direction or whatever, so it's not going to tell me the direction, just the magnitude of it. And how do we do that? And this is defined as a b cosine theta. Okay, so a is nothing but a vector, b is nothing but a vector. So these two vectors, if you are dot multiplying, okay, dot multiplying, then or dot product. So if you do the dot product of it, then it's going to give it will be given by the magnitude of a, magnitude of b, and the cosine angle between those two things. Okay, so if how many of you know what is sine 0 is? Sine 0 is 0, okay? Cosine 0 is? Okay, and sine 90? Okay, and 30 degrees, okay. And cosine 90 is? Okay, so these things, the basic things, and in the same way 180 and for sine and cosine also. So those are some basic things I want you to remember. And similar way, let me write this one. Sine of 180 is going to be, anyone knows?
0.
And how about cosine of 180?
Negative 1.
Good. Okay. So this is 0, 2. This is negative 1. So these are some basic numbers I want you to remember for your future uses. And anyway, so if this is that, if I have a vector A, vector B, and they have a 90 degrees angle, what do you think of the dot product of those two without doing the math? Tell me. 0 or 1 or any other number? Without doing math, you tell me. I did not give you what is A and what is B, but what I told you was that the angle between them is 90 degrees. And I want you to tell me what is A dot B. What is A dot B? Somebody is saying that, not confident enough though. 0, right? See this one, A dot B is defined as magnitude of A, magnitude of B. I don't know those things, so I'm just going to write as it is. But I know the angle between them, right? That's going to be cosine of 90 degrees. And we know cosine of 90 is nothing but 0. 0 multiplied by any number is going to give me a 0. So I don't even need to know if they're this big or this big. All I need to know is the angle between them. If I know the angle between them, then I can simply, if the angle between them is 90 degrees, then I simply know the dot product of it is going to be 0 because they are perpendicular to each other. Okay, and in the similar fashion, if I have A is this size, okay, I have a vector like this, and I have a B vector in the same direction, but a little bit longer thing right there. So if I want to find out what is the A dot B, how much that would be the answer? You thought correct, but a little bit mistake you are doing. So this one you already know, right? So I'm just going to erase this one right here. What is the angle between A and B? How many of you say it is 0? All of you know it is 0? They're on top of each other, so there is no angle between them, right? So it means the angle between A and B is a 0. We already know that. I mean, we know that from the picture right here. So if you want to find out A dot B, you need to find out what is magnitude of A and what is magnitude of B and cosine of 0 right here. So cosine of 0 is 1, so I'm just going to, right? So if I know how long this one is and how long this one is, just put those numbers. That's going to give me the dot product of those two vectors. Okay, so it's not 2, but it is the magnitude of those two. So it's just that this cosine thing would be taken care. So now you know that if you know the angle between those two, then you know how to find out the dot product of those two. Like if you know if it is 0 or 90 degrees like that, then you can simply do it in your mind itself and you can tell the answers. Okay, so that's about the dot product. And when you do the dot product of two vectors, such as let's say if you have if I gave you the angle between them, you do AB cosine theta like that. Okay, so I say if one is like this, one is like this, and it is angle is whatever, then you do the first formula right there. But if you are doing the second way, that is I give you A is nothing but like 1I, 2J, 3K, and if I give you B as 2I or 2K plus 3J, something like that. And if I ask you to find out the dot product of those two things right here, so which is going to give you just a number, no directions at all. So if you want to find out this one right here, then what you have to do is 1I, 2J, 3K, dot 2K, 3J right there. So you're going to multiply the I things with I things and J things with J things and K things with K things, and you add them up. Okay, so when you have a dot right here, so right here I have 1 right here, so I have to multiply I times I and I times I, which is I dot I. What does that mean? I is a vector and I is a vector. So what is the dot product of these two? What is the magnitude of I? I just used a word for that. What I, J, K are? Good. It means they are unit vectors, right? So it means their magnitude is 1. So we don't have to mention it every time that, you know, when you do the dot product of it, I magnitude is 1, so that is 1, and I magnitude is 1, that's there. And the angle between I and I is 0, right? So that is cosine of 0. So that's going to give me 1, right? So 1 times 1 times 1 is 1. So that's why when you multiply, so you multiply these, the I things with I things, and you don't put any number or anything with that because that angle is 0 between them. Everybody's following? A little bit confusing? Kind of. Okay. So it's not tough, but I just want you to, if you can remember it, like, you know, you multiply I times I, J times J, K times K, that's all. That is fine. But why we don't care about it? after we multiply with, this is the thing. So we just put a number, we don't put any angle or any I or anything anymore. Why? Because the I dot I is nothing but just 1. That's why we are not going to carry those I or J or K anymore. Once we multiply, we just leave them alone because the product of those things will be 1. So once you have right here, when you're multiplying this, do I see an I right here? So what is my I? Okay, so you're going to multiply that 1 with 0, so you get a 0. And then plus 2 times, which number should I multiply with? 3, okay? So you just go with J, even though it is not written in the first, but J with J, so that's going to be 2 times 3, which is 6. And J times J is going to be 1, so you're going to leave it alone. Then this 3 times this 2, which is again 6. And K times K is 1, so you're just going to leave it alone. So your answer would be 12. So you see this one right here, even though these two are vectors, the dot product is giving you a number, which is a scalar. So that's why we call it a scalar dot product. Okay? And in other words, when you're writing this one right here, so we call it as AX. This is AX, AY, AZ. So these are that, right? This is the X component, Y component, Z component. So when you're multiplying, we can simply write AX, BX, AY, BY, AZ, BZ, and you add them together. Okay, so that's just the formula for that, and you remember however the way you want to. And then there are some properties right here. If A and B are perpendicular, it means the 90 degrees. Cosine is 90. Cosine 90 is 0. So that's going to give you a 0 product. And if they are parallel to each other, it means the angle between them is 0. So cosine 0 is 1. So whatever you multiply, then you get just their magnitude as their answer. So A dot B will be nothing but the magnitude of A times magnitude of B. And if A dot B is 0, it means either A is 0 or B is 0, or both of them are perpendicular to each other. Okay, so that's what is. If you have A dot B is 0, then this 0 or this 0, or those are perpendicular to each other. So those 3 are the key rules. And then if you want to find out A dot A, it is simply magnitude of A times again magnitude of A. Okay, so because A is perpendicular to itself, right? So the cosine of 0 is 1. So some of the rules like A dot A is nothing but A square, because magnitude of A, and the angle between them is cosine 0. This is 1, so A times A is A square times 1, so it will give you A square. And in the similar fashion, A dot B is exactly same as B dot A, because the angle, if I say angle between this and this, whatever, if you say this and this or this and this is the same thing. So that's why if you have a whatever the angle, and the answer for this one is AB cosine theta, and this one is also BA cosine theta, let's say. So it's the same thing, right? AB cosine or BA cosine. That's why A dot B is same as B dot A. And if you add A plus B and you make the dot product of it, it is exactly same as you take the dot product of A and C and then you add it to B and C. You still get the same answer. So the last statement right there, which is A plus B dot C, do you think it's going to give me a scalar or a vector? The last statement right there. Is right? Okay, so A plus B dot C. This is the question right here. So what this A plus B gives me, does it give me a vector or a scalar? Okay, most of you know it. So because I'm adding a vector to vector, so you get a vector again. So think that you got some X vector. And then you are dot producting with this C right here. So when you dot product of any vector to any vector, you get a scalar, right? So no matter, and in the second case right there, that is exactly same as we said A dot C plus B dot C. So when you do A dot C, you get a scalar, and when you do a B dot C, you get a scalar, scalar, and you add a scalar, you get a scalar. So don't be thinking that, okay, how is it correct? Because you get a vector definitely, but you are multiplying again with C, so you get a scalar, and this is two scalars you're adding, okay? So that is that. And shall I go ahead or shall I stop right here? No, I mean, I want you to follow it actually, so. And I have so the next is cross product. So I will just